Now I'm going to show you how you can speed up your training time using PCA. So I'm going to train my model without PCA first, then I'm going to train with PCA. And this way I'll show you how the time increased. Also, I'm also going to show you how your accuracy was not compromised much. So now I'm importing my necessary libraries. I'm importing fetch OpenML. This is responsible for fetching your dataset. I'm importing my PCA. That's responsible for principal component analysis. I'll be using logistic regression model. So that's why I'm importing this. This is for scaling my data because you want, PCA, data needs to be scaled. Then I'm importing my train test split method. This is going to be responsible for splitting my data set into training and testing, and also for accuracy score for checking the accuracy of my model, how good my model is. Okay, so first thing I'm doing is fetching my data set. I'm using MNIST 784, and then I'm just printing my shape of my data set, and it prints out. You can see it has 70,000 images, and each image has 784 features. In other words, 784 columns. Then I'm splitting my data into training and testing. So over here, I'm using my inbuilt method, train, test, split, and I'm specifying my test size. In this case, it's 20%. And in this way, it actually splits into X training, X test, Y training, Y test. And then I'm printing one of the image just to see how it exactly looks like. So I'm printing the first image or first record of my training data. So as you can see, this almost looks like 5. So let me decrease the size of the screen so you can see that. And you can see from the outline, this looks like 5 right here. So this, it goes like this, and like this. So all these numbers are finite number. The rest of the numbers that are outside this area, they're all 0. And so all the numbers in here, they will be between 0 to 255. 0 all the way up to 255. 0, it means that your pixel is black. Okay, so this is your black, and this one is your white. So you can see these values right here, they're all black colors. Okay, these are all black colors, but this one right here, these areas, they are not black. There are some colors to that. They're white. Okay, all these regions. So you can see some of the numbers is 234, 253. So they refer to like how white they are. Okay, now let me increase the size of the screen. All right. Now scrolling down, I want to plot this image because, okay, I was able to see visually the numbers, but now I want to see how it exactly looks like when you plot that using Matplotlib library. So I'm passing the same image, Xtrain, the first record of my Xtrain. And now you can see that it is exactly 5. Okay, so this is your 5. Okay, so now I'm scaling my data. This is important for PCA and logistic regression. So I'm using standard scaler, and I'm passing my X train, and I'm also passing my X test to there. This way it scales both my training and testing data. And then after that, I'm printing the first value of my training data, the same one I just showed you a minute ago, that the number 5. And this is what it prints right here. You can see the numbers now are all scaled down. They are no longer between 0 to 255. These are more like numbers in the range of, like, with the mean value of 0. So you're going to see some numbers like between -1 to +1. Okay, now I'm importing my time. This will be responsible for determining how much time it took to train my model. So first I'm training my model without applying PCA. So I'm applying maximum iteration, I'm saying 1000, and I'm using this algorithm, LBFGS. This stands for Limited Memory Broyden Fletcher Goldfarb Shano. And one of the advantage of this algorithm is that it uses very little memory, and it's very good for high dimensional data. So in this case, I have 784 features. So in other words, 784 dimension for each image. So this will be a good option for that. Okay, so I start my timer right here. I train my model over here. I end my timer, and then I check my time difference, how much time it took. I'm just subtracting your end time with start time, and then I'm printing my training time over here, how much time it took me to train without my PCA. Then I'm also doing some accuracy comparison. So I'm testing my model on my X test data set right here. And then I also have my result for my Y test anyway. So since I already have the Y test, I'm comparing my Y test with my test that was predicted, the y test that was predicted from the model. So that gives me my accuracy score. And this way I'm printing my accuracy without my PCA. You can see that training time without PCA took me 22.22 seconds. And the accuracy in this case without my PCA was approximately 91%. Now let's apply PCA. So in this case, I'm choosing 100 components, and this is my training data set with PCA. This is my testing data set with PCA. Then I'm checking my original shape. In this case, my original shape comes out to be 56,784. This was my original image. 784 is the number of features or a number of dimension, and 56,000 that refers to the size of your training data set. Now, after you apply your PCA, I print my X training and I'm printing the shape of my X training data set after the PCA, and you can see that your features has gone from 784 to just 100. So dimension went from 784 to 100. In this case, the total variance that was captured by first 100 principal components is approximately 70.4%. Now I train my model, and this time I'm using my PCA, my XPCA. So I'm using my logistic regression model, maximum iteration same 1000. I'm using the same solver, and then I'm starting my timer. I train my model. I'm giving my X training data, which with PCA now, and then I'm ending my time over here, and then I'm calculating my time difference just the way I did before, and then I'm printing my training time with PCA, and I'm also doing the same thing with the prediction. I'm also trying to predict my values based on this X test PCA. So this is the X test after it was applied PCA. And then I'm printing my accuracy score over here. So in accuracy, by the way, not 50, this should be 100, 1, 0. So accuracy with 100 component. So if you can see that over here, you see it training time with PCA was 6.48 seconds, and the accuracy with PCA with 100 components was 91.6%. So this one is 91.6%, and the before it was 91.64%. You can see the accuracy has not dropped significantly. It's just almost pretty much same. But the time definitely it saved. You can see that 22.22 minus 6.48 divided by 22.22, and the answer is 70.8. So you have saved 70.8% of the time. So conclusion, apply PCA. With PCA, your machine learning model, they train faster. And also, your accuracy in this particular instance was almost the same with or without PCA. So applying PCA is very helpful.